Find the surface area of revolution obtained by rotating the given curve about the given axis. So this is a parametric equation problem, okay? We will find its surface area. And to do that, let's graph it. But before we do that, we need to find an equation that has a y is equal to x relationship. The way we do that, okay, is from this equation, right? We divide 3 on each side and square each side. Yeah, square each side. Then we get the value of t. Then if we put it in there, we get y is equal to x relationship equation. So now we have y is equal to 2 times x over 3 to the power of 3 over 2, okay? So now let's graph this. When we do, this equation looks like this. And if this is 1, 2, 3, 4, 5, this imaginary, yeah, from the interval from 0 to 5, okay? So we have that. And then this will spin across the y-axis, okay? Which I will reflect this image across the y-axis, okay? And it will spin around one, okay? It will spin around one. And it will probably, it will make a circular base, yeah? And then it's the same case for the top. Well, yeah. But the thing is, the base is a solid, okay? So this 3D object, let's just pretend it's a 3D. I pull it out on the bottom. If I poke with this, it's gonna block it because it's solid on the bottom. But it's not, it's just opened but there is a like donut kind of thing, but it's way thinner, so yeah. I want to find its surface area. To do that, I will draw a band, okay? A rubber band, okay? So a band, it looks like this, okay? Will spin across the wax, okay? It will make a little circular ring. Oh, that's a good drawing, okay? But you guys can't see it with all the crazy lines, so I will draw another one for you guys. Okay, it looks like this. I think that's a perfect demonstration of what I just did here, okay? This thing, right? Well, before we get to that, this rubber band, right? Let's cut it in half, okay? And then let's straighten it up. So I get this long rectangular thing, okay? Do you know what this side is? It's ds, okay? So this thing is a ds. And let's find the length of this, okay? What is that, okay? Okay, so for example, okay, let's just use my finger as an example, okay? Okay, so this is this, right? And this length, okay, this length, if I just fold my fingers back into a circle, that's a circumference, okay? That is a 2 pi r. But do you know what r is? R is this. The radius is this, okay? And do you know what another thing r is, okay? Wait, yeah. Yeah, so this thing is r, but also x. But x is 3 times t squared. So I will change that into a 3 times t squared. And I will also change it by 6 pi t squared. 2 pi, yeah, okay? And when I multiply them together, which then I will get the area of this, which is 6 pi t squared ds, that, okay, is the surface area of this rubber band. Okay? And also, if I set the integral from the interval from 0 to 5 of this, 6 pi can come in front because that's the coefficient, and t squared ds can stay here. Okay, this rubber band was the surface area we just found, which we just found that it was that. Okay. But now it has the interval, okay, the integral from 0 to 5 right here. Wait, no, 0 to 5 right here. That means it will have infinitely many amount of this rubber band, okay, which eventually it will, let us find the surface areas for us, okay? So now let's solve this, okay? What is ds? From our previous video, we know that ds is equal to dx plus dy. Actually, it is squared. And when I square root each side, I get square root of dx squared plus dy squared. Okay? So let's put it in here. We need more room, so I will erase all of this right here. So we have a new equation that we will solve for. And this is that, so... And now, let's divide, okay? Each side by dt. So we have this, and we also have to multiply dt because since we divided it, we multiply dt, so it's like as if nothing happened, okay? It's like 1 plus 1 minus 1 is 1, okay? So we have that, and now let's find the value of dx over dt squared and dy over dt squared. Dx over dt squared is this. If I differentiate that, I get 6t, but I have to square that. Oh, okay. So dx over dt squared is equal to 36t squared plus dy over dt. Okay, is this. If I differentiate this in a square, I get my dy over dt squared. So that is equal to 6 times t squared, and when I square that, I get 36 times t squared. And, of course, times dt. I'm again running out of room, so now let's work on the inside of here. Oh, it's supposed to be to the power 4, not 2. Okay. Let's work on the inside of this. Okay. We can, group 36 and t to the power of 2. Okay, so 36 times t to the power of 2, okay, times 1 plus t squared. And times dt. Okay. And this both thing can okay, so 36t squared, okay, is equal to 6t now, because we square root that. And yeah, 6 can come in front because that is the, coefficient. So that is 36 pi times the integral from 0 to 5, t squared, square root of 1 plus t squared. Nice. Okay, everything looks perfect. Okay, from here, I will use the substitution rule. And I think this can go away. Okay, from here, I will use the substitution rule. Okay, which I will set the u is equal to 1 plus t squared. Okay, so du is going to be 2 times t times dt. Also, another thing I will put is I will subtract 1 on the both sides, so I get, so I get this. Okay, wait a minute. Pretty sure I made a mistake somewhere. I just found my mistake, okay? The 6t, remember? Yeah, I multiplied 6 because that's the coefficient to here, but I forgot to multiply t to here, okay? So now that is just t cubed. T cubed. Okay, now let's separate this into t squared times t square root of 1 plus t squared dt. Okay, and now we can use these 3 substitutions we just found, okay? U is equal to that, so let's do that first. Okay, so this is equal to square root of u now. And from here, I will divide it to 1 each side. Okay, so t times dt, this and this cancel out and be replaced by du. And 1 over 2, which it can come up here because that's the coefficient. And this, right? Yeah, t squared, okay? Now that is u minus 1. Okay, so now let's solve for this, okay? We are so close there. Well, another thing I forgot is this interval, right? That was in terms of t, okay? So t is equal to 0, 2, t is equal to 5, okay? And now we have to put it in there because we just used the substitution rule, so let's put 0 into there, which will get u is equal to 1, and 5 into there, we get 26. Okay, so let's erase all of this. Okay, so now let's work on the inside and do a little bit of that, okay? So 36 over 2 is equal to 18 pi times the integral from 1 to 26, and u minus 1 times square root of u, okay? U times u, no. U times square root of u is equal to u to the power of 3 over 2, and 1 times square root of u is equal to square root of u, or u to the power of 1 over 2. Okay, and we have the du. Okay, that's great. And now what we can do is integral them. Okay? Okay. So I integral them. Oh, I don't need the integral sign anymore. Okay. When I integral that, I get 2 over 5 times u to the power of 5 over 2 minus 2 over 3 times u to the power of 3 over 2. Okay. And the interval from 26 to 1. Let me see if that's right. Yep, it's right. Why wouldn't it be? Okay. So I will leave it up to you guys once again to do it yourself. Okay? Else you guys got to do something. So whatever you will get your answer, okay? Let's call that, I don't know, like star, okay? Star is the surface area of this thing. Messy, but yes, I explained it so you guys should know. If you guys have any questions, let me know down in the comment section down below. I will get it and answer it back to you guys as soon as I get them. So see you guys in the next video. Bye.